right, so today we're going to talk about some right triangle trigonometry. We're going to talk about sine, cosine, tangent, which you have seen before in geometry, and there are 3 new ones that you may have not seen. So we're going to talk about those as well today. So if we're talking about the sine, cosine, or tangent of something, it is like you have to have it of something. So it's of an angle, the sine of an angle, the cosine of an angle, the tangent of an angle. And if you have an angle, the sine is always this relationship between the opposite side and the hypotenuse. So if you have, let's say, a 30-degree angle measure, the relationship between the opposite and the hypotenuse, no matter how big or how small you make this triangle, as long as it's a 30-degree angle, will always be the same. And so that's what we're kind of doing here, is we're referring to, okay, the relationship of this angle of the opposite to the hypotenuse, always the same. Same thing with the cosine. Let's say you have the cosine of 45. Well, the cosine is the relationship between the adjacent side and the hypotenuse. And so no matter how big or small this triangle is, as long as we're talking about a 45-degree angle, this fraction will have the same value. It'll be the same thing. And then tangent is the relationship between opposite and adjacent. And so a lot of people, and you might remember this as SOHCAHTOA, SOHCAHTOA, right? SOHCAHTOA. And so in terms of a triangle, let's go ahead and talk about what we're referring to. So any angle here, or this one could be theta, just depending. The opposite is the side across from it. The hypotenuse is always the one across from the 90. And then that makes the adjacent, the side that's next to or connected to, forms that angle, but is not the hypotenuse. So that would be your adjacent side. If we were to change where theta was and put theta up here instead, then these two would swap locations. Across this side would now be the opposite of that angle, and this one here would be the adjacent. Your hypotenuse, though, is still your hypotenuse no matter what. So the first important feature down at the bottom, well, not the first one, but one of the important features is that the opposite and the adjacent sides depend on which angle you're going to use. So if you're using this angle, you have opposite adjacent, this angle, opposite adjacent. It just is going to depend. All right. Cosecant, secant, and cotangent are based off of sine, cosine, and tangent. And so the cosecant, we can refer to that as the reciprocal of tangent or of sine. So that would be 1 over the sine. So what that means in terms of the opposite and hypotenuse relationship, instead of opposite over hypotenuse, it is hypotenuse over the opposite. So that relationship is just reciprocal. It's just flipped over. The same thing is true for the secant. It is 1 over the cosine of theta. So instead of adjacent over hypotenuse, it is hypotenuse over adjacent. And then last but not least, cotangent. Same thing. It is the reciprocal of tangent. And that would make this, instead of opposite over adjacent, it just gets flipped around. Adjacent over opposite. And so it'd still be based off an angle. So if we're talking about this angle here, we're talking about the same opposite, adjacent, hypotenuse. And so there's 6 more trig functions that have a slightly different relationship. It's the reciprocal of our original 3. And so that what happens is we just flip it around. All right, so some other important things to remember about the trig functions. They only work with right triangles. If it's not a right triangle, you can't use sine, cosine, tangent unless you can somehow form right triangles as a part of the triangle, like split it up or add on or do something to make right triangles. And then last but not least, the trig functions, you can use them to find missing sides, like the Pythagorean theorem, or you can use them to find missing angles. Both will work. So missing sides or missing angles. So that's kind of a nice additional feature. Pythagorean theorem is just sides, where trig functions are sides or angles. All right. So We're going to go ahead and find the value of all 6 of the trig functions. So we're looking for the sine of theta, the cosine of theta, the tangent of theta, the cosecant of theta, the secant of theta, and the cotangent of theta. And we're going to say what all of these are equal to, all of these relationships. So here is our theta, angle theta. So what we have currently is the opposite and the adjacent, and we are missing information about the hypotenuse. Now the nice thing is if you have 2 sides, you can always find the third side, right? You can use the Pythagorean theorem. So Pythagorean theorem this, or if you recognize 9 and 12 as this is 3 times 3 and this is 3 times 4, this is a 3, 4, 5 that has been multiplied by 3. So this side would be 15. So it is a Pythagorean triplet going on there. If you don't notice that though, you can always Pythagorean theorem. All right, so the sine of the theta, the relationship between the opposite and the hypotenuse, is 9 over 15. And you should simplify when possible, so 3 over 5. The cosine relationship is 12 over 15, so that will simplify to 4 over 5. And then your tangent relationship, that's opposite over adjacent, so that was 9 over 12, which simplifies to 3 over 4. So whatever this angle measure is, the sine of it has this relationship. Even if we make this instead of like 12, 9, 15, if it was just a 3, 4, 5, it would still have the same relationship. If we made it bigger but kept the angle the same, we would have the same relationship here. So no matter how big your triangle or small your triangle, whatever angle you have, as long as the angle itself is not changing, then it has the same sine, cosine, and tangent relationships. All right, for the cosecant, how I remember that cosecant goes with sine is that the s goes with the c and vice versa. The c goes with the s. And then this one, tangent and cotangent, those ones are pretty obvious that they should go together. So kind of remembering them, sine goes with cosecant, the s goes with the c, not the s with the s. So cosecant is 1 over our sine. So what's going to happen here is we're going to take our answer and it's the reciprocal of it. And the reciprocal is just to flip it over, 5 over 3. Secant is the reciprocal of cosine. So if cosine is 4 over 5, that would be 5 over 4. And then cotangent is the reciprocal of tangent. So just flip that one over, 4 over 3. You could also go back to your triangle and go up and know that the cosecant is opposite over hypotenuse, what we wrote down before, and do hypotenuse over opposite and then simplify. You would also get 5 over 3. But it's actually going to just be easier and more beneficial if you just know that it's the reciprocal, so just flip it over. All right, number 3, same thing. Figure out all 6 trig functions based off of that angle theta. So we're going to have sine of theta. We're going to have cosine of theta, tangent of theta. And then sine will go with cosecant theta. Cosine goes with secant of theta. And tangent goes with cotangent of the theta. All right. So to find the sine of this angle, we need the opposite, which we're missing, right? So we're going to have to figure that out. This is not a Pythagorean triple, 8, 9 something. So you just have to use the Pythagorean theorem to figure it out. So we would do 8 squared plus our side we're missing, we'll just call it x squared, equals 9 squared. And then we'll have 81 minus 64 is 17. So this will be the square root of 17. And it doesn't simplify, so we're good. Square root of 17. All right, so using that as our opposite, we have square root of 17 over 9 for the sine relationship. If this simplifies, you should simplify it. If you need to rationalize it, so if that square root are in the denominator instead of the numerator, you should do that as well. If there's nothing that you can do, no simplifying, no rationalizing, then it's good and you can just move on. Cosine would be 8 over 9. And the tangent would be square root of 17 over 8, opposite over adjacent. And then for these three, if you just remember that it's the reciprocal, that would be 9 over the square root of 17. Now this one does need to be rationalized. So when you go to rationalize it, you're going to times by the square root of 17 and the square root of 17. So this will be 9 square root of 17 over 17. You do not have to show that step because rationalizing this is not actually that hard to just kind of know how to do it in your head. So the top and the bottom both get multiplied by that square root. So it appears in the numerator, and then because there was already a square root in the denominator, the square roots go away and you're left with just 17. If the 9 and the 17 could simplify here in the numerator or denominator, you should simplify those, but they can't. All right, secant, that would be 9 over 8. And cotangent would be 8 over the square root of 17, which does need to be rationalized. So it'd be 8 square root of 17 all over 17. And once again, if the 8 and the 17 would simplify, you should do that. But in this case, they don't. All right. So now what we're going to do is we're going to use our trig functions to go ahead and find missing side lengths or missing angles, solve the triangles. So for this piece, you're definitely going to want to use your calculator. If you have a phone, you should be able to use a calculator on your phone. Turn it sideways. You should have access to the sine, cosine, tangent functions there. If you don't, and you can go on to Desmos. I'll put a link in the with the notes today, like the instructions for today. I'll put a link to the Desmos calculator, and you can use that one to help you out as well. All right, so we have an angle. We have two sides missing the hypotenuse, and so we're going to solve for x using one of our trig functions. So based off of this angle here, we would say this side is the opposite. This side is the adjacent. And so you need to pick one of your trig functions that is the opposite and adjacent. So your options are based off of what we had here, either tangent or cotangent. And it is completely up to you. You can do this with tangent. You can do this with cotangent. I will let you know that doing it with tangent is easier because your calculator has a tangent button. It doesn't have a cotangent button. And so this would be a little bit harder to manipulate in the calculator, but you could still do it. All right, so we're going to go tangent. So we'll say the tangent of the angle 55, that the relationship between the opposite and the adjacent, x over 10. All right, solving for x. Right now it's in the denominator, so we need to get it out. So we're going to multiply it up. So this will be x times the tangent of 55 equal to 10. And then last but not least, you can divide by the tangent of 55. So it would be 10 divided by the tangent of 55. Now, one thing if you're in class that you're going to have to pay attention to is that your calculator can do things in both degrees and radians. We'll talk about radians next week. And so you're just going to get more comfortable as the trimester goes on, going back and forth between the two. So if you hit mode right here and go down, your calculator might have radians selected. And if you want it in degrees, because this is 55 degrees, you should just move over and hit degrees. Most likely there's a spot on your calculator as well that goes back and forth between degrees and radians. So if you do this calculation and you don't get the same number that I do, just know that it's probably because you're in the wrong mode. So 10 divided by the tangent of 55. So we have 7.002. In terms of rounding, you can just round to 2 decimals. That would be fine. So in this case, it would just be 7. So this side length x is 7. All right. Up next, we have an angle here, 46 degrees. The 12 is the opposite of it, and the x is the hypotenuse. So you're going to want to pick a trig function that deals with opposite and hypotenuse. And you have two options. You have sine or cosecant. There's no cosecant button, so going with the sine is actually easier. So sine of 46 equals opposite over hypotenuse. It'll solve just like the other one did where you multiply by x and divide by sine. So if you just go ahead and jump straight to this, I'm fine with that. That's nothing too crazy. And then just throw it in your calculator. So we have 12 divided by the sine of, 46. And so I get 16.68. So it'll round, or it'll stay. It doesn't round. It just rounds to itself. 16.68 is that missing side. By the way, it does make sense that your hypotenuse, the one we found, is longer than your opposite side, right? If I got a number here that was like 9 or 10, I'd be like, wait, hey, that doesn't make any sense that my hypotenuse is shorter. So if you didn't get this number and this is what you typed in, probably you're in the wrong mode. So you're going to have to figure out how to change that for whatever calculator you are using. All right. Now we're going to find the measure of the angle. So instead of having the angle and looking for a side length, we actually have two side lengths here, and we're going to go back and find the angle. So based off of this angle, what do we have? This is the hypotenuse. This one's the adjacent. And if you have hypotenuse and adjacent, you're going to want to work with cosine. You could do secant, and when you guys are all back in person, I'll show you how you could do that. But for now, just go with cosine because cosine has a button on our calculator. So cosine of the angle, remember you always have to have cosine of an angle, cosine of something, right? That relationship is 10 over 12.3. And so in this case, we're trying to solve for the angle here. So to get to the angle, we have to get rid of this cosine operation. You should think of cosine as like an operator, like a square root or a square or a plus or a minus. Like it's an operator that you have to undo. And so to undo cosine, you're going to do a cosine inverse. So theta would be equal to the cosine inverse. And the inverse we denote as the negative second or negative first power here. And we'll cosine inverse 10 over 12.3. Now on your calculator, the cosine inverse button is directly next to the cosine button. So whatever the cosine, its inverse is here in blue behind it. Same thing. If this is a sine, sine inverse, tangent, tangent inverse. So to get to those, you have to hit the blue button first. So you should be able to get to those or have those buttons appear on whatever calculator you are using as well. And then just type in 10 divided by 12.3. Make sure I have those. Yep. And we have an angle measure of 35.61. Once again, if you didn't get this number, if you got maybe like a decimal here, most likely you're in the wrong mode. So you should change that. All right, so next one, looking for the missing angle here as well. We're going to go ahead and set up one of our trig functions. It looks like based off of theta, we have the opposite and the adjacent. So the best one to use here is tangent. You could use cotangent, but your calculator probably doesn't have a cotangent button. So opposite over adjacent tangent is just a whole lot easier. So 3 over 7. So you're going to tan inverse the 3 over 7 to get your actual angle. So tangent inverse, 3 over 7. We have 23, and it'll look like it'll round to a 0.2, so 23.2 degrees for that angle there. All right, so hopefully that was a nice kind of refresher to finding sides and angles. You did do it in geometry, so it shouldn't have been new, but maybe something you haven't seen in a couple years. All right, we have solve each triangle. So when it says solve each triangle, you're literally solving for everything. Solve for any missing angles, solve for any missing sides. Just solve the entire thing. Make sure you have all of the possible information for this triangle. So the first thing I noticed is I'm missing this angle here, angle A, and then I'm missing this side, CA, and then I'm missing this side, CB. And so you can solve them in any order that you want. It does not matter. There's probably like 80 million different ways you could go about solving this in different orders, using different trig functions, completely up to you. So the first thing that I want to point out is if you have two angles of a triangle, it's really easy to find the third one because all of the angles in a triangle add up to 180. So we know 39 plus 90 plus whatever angle A is has to be 180. So you can just do some subtraction here and get that angle A should be 51. So here is a 51. Now to solve for the missing sides, you probably are going to have to do some trig, but you have a lot of options. You can pick which angle you want to work with. If you want to work with the 39, then this would be opposite and this would be adjacent. If you want to work with the 51, this would be opposite and that one would be adjacent. So just kind of know that I'm going to pick one of them and work with that. You could pick the other one and use different trig functions. So I'm going to pick the 39. And I'm going to go ahead and solve for this side AC first. So I'm just going to label it X so I have a variable to work with. And that would be opposite and hypotenuse. So that'll be the sine function. So sine of 39 equals X over 3. So to solve for X, you would just times by 3. So when you type this in your calculator, it's easiest to do 3 times the sine of 39. If you type in the sine of 39 first, you have to close this parenthesis. If you just type in times 3, then it's going to actually do the sine of 117, and you don't want that. So close the parenthesis, then hit times 3. That would give it to you as well. So either this one or this one, but not that one. Don't pick that one. That one's wrong. All right, so it looks like our side is 1.89. So we have this side, 1.89. All right, and last but not least, we need to solve for this other side, side Y. I'm just going to label it Y so it's different and I have an actual variable for it. And there's tons of ways you can do this. You can use the 39 and use cosine. You could use the 39 and use tangent and use this number to do a tangent. You could use the 51 and do a sine of 51. Or you could use the 51 and do a tangent. Or, because you have two sides and you're missing the third, you could Pythagorean theorem. Completely up to you. I actually think Pythagorean theorem is the hardest here. I'm just going to stick with the 39. And instead of sine, I'm going to go with cosine. Y over 3. So this would be 3 times the cosine of 39, which means that that side is 2.33 on the rounding. So 2.33. And if you look at your sides, so you have the two sides here, you have your hypotenuse here at 3, so it makes sense that, yes, technically this is longer, right, than those two, so we're doing okay. If we got a number here that was bigger than 3 or here that was bigger than 3, I would say, whoa, we got an issue going on. All right, I would say pause the video right now, try number 9, see if you can solve it all on your own, and when you're ready, go ahead and hit play, and I will have the solutions, just the answers up there for you. All right, so this side is 10.39. This angle in here, that is actually a 30-degree angle, and this angle is a 60-degree angle. So if you solve this, you should have gotten these. If you use the Pythagorean theorem here, you would have had the square root of 108 instead, which would have simplified to 2 square root of 27, which then would have actually continued to simplify to 6 square root of 3, I believe. Right? 6 square root of 3. And all of these are all equivalent. They're all equal to 10.39. So if you Pythagorean theoremed, you probably were somewhere along here. But if you use trig, you would have gotten this decimal. And so on this particular problem, either the decimal or this one would have been okay, acceptable answers. And then for your sides, it was a 30, 60. I don't know if anybody noticed that, but this was 6 and this was 12, and that's times by 2. And this was your smallest side, so that had to be a 30. So 60. All right, last type of question, we're going to find the cosecant of theta if the sine of theta is 3 over 5. And so there's the relationship between a sine and a cosecant, right? It says that the cosecant of theta is 1 over the sine of theta. So it's the reciprocal of theta. So if sine is 3 over 5, then cosecant is 5 over 3. And it's as simple as that. Now, let's say instead of cosecant, let's say I asked you to find, I don't know, cosine instead, given that sine was 3 over 5. You can't use a reciprocal identity. It doesn't work that way. So what you would have to do in this case, if you can't do a reciprocal, you can go ahead and draw yourself the triangle. Pick one of the angles to be theta. It doesn't matter. So I'm just going to pick that one down there as theta. The sine is opposite over hypotenuse. So we would put 3 over 5. And to find the cosine, you would need the adjacent. So how would you find the adjacent? You could Pythagorean theorem, or hopefully you notice that this is a Pythagorean triple, so that makes this side equal to 4. So your cosine would be 4 over 5. You could also do this method if you had to find tangent or cotangent or secant, anything that wasn't the reciprocal version. So if it is the reciprocal, then go ahead and just take that. It's not really a shortcut. You're just using the reciprocal information to go ahead and flip that. If not, draw yourself a triangle. So this next one, find the cosecant, or find the cosine if secant is 17 over 8. So these are reciprocals of each other. So that would make the cosine of theta 8 over 17. Now, if we asked you to find maybe like the cotangent, then that would be a little bit harder because you'd have to set up a triangle, pick an angle for theta. Based off of the secant, this would have been hypotenuse over the adjacent side. So you would need this side, and you could Pythagorean theorem, or maybe you recognize it's a triple, and if you did, that side was 15. So cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, cotangent is adjacent over opposite. So this would have been 8 over 15. So if you're ever not sure, you can always draw yourself a triangle and go ahead and do the calculations there. But sometimes they are the reciprocals of each other. And if they are, then you're good to just go ahead and flip that over and keep on moving. All right, so your homework is the next 4 pages. Everything should be pretty similar to what we saw in the notes today. So find all the 6 trig functions, find the measures of each of the sides, find the angles. On the next page, we have solve the triangles. So tell me all the sides, all the angles. Find each of the values given one of the other values. And then we have a couple story problems to work your way through. So let me know if you have any questions. We are going to have a quiz when you come in on Wednesday about the trig, sine, cosine, tangent, cosecant, secant, cotangent, as well as Pythagorean theorem, 45, 45, 90, 30, 60, 90 triangles. We will have some time before we start, though, if you have any specific questions. But if you have a section that you have a lot of questions about, please reach out before that.